Yeah, yeah. Now we hear you. We are listening.
Thank you so much. First of all, let me thanks the organizer for giving us this opportunity. Also, I thank Dr. Mori for his great poster and introducing our quantum biology lab. Uh, Today, in fact, I'm Mohsen Izadyari, a postdoc researcher at Quantum Biology Lab at Howard University in the Washington, D.C., working with Dr. Korean as a PI of the group. And today, in this work, I'm going to introduce a work based on the quantum heat engine with using the network of the three-level systems as a working medium. And what we have done here is based on the two different systems. One, the network of the three-level systems in a cavity and also in the free space, two different setups. And we show how the collective effect of this network can increase the work output of the heat engine and also how we can reach in fact, to generate the non-classical anti-bunch light with thermal noise. At first, I'm going to introduce this system in the cavity. In the cavity-based system, we use the tryptophan molecules that are modeled as a three-level systems. And we consider in fact, the ring of the tryptophans, as you can see in the figure 2 here. And by increasing the number of the molecules, we can see that generated photons in the cavity significantly increases. And I need to mention that how we can model the quantum heat engine, you can consider the three-level system in the right side, upright side of the poster. We have a three-level system that hot bath couples the excited state to ground state, and also we have a cold bath coupling the ground state excited state to the middle state, and the transition between the middle state to the ground state will be our work output for both setups. So what we saw that it is in the by increasing the number of emitters when there is the dipole-dipole interaction between them, it's significantly the generated photons is increasing. And also, I used two maybe extra slides, and I hope it's not a problem to show that because maybe it's better to see. So as you can see, by increasing the number of the emitters, we can see the increasing the number of the photons in the cavity, and in the even we plotted in the for NH and the photon numbers of the hot bath. So by even this under formats of the tryptophan, it works in a high temperature efficiently as well. And also by increasing the number of the emitters, we can see that G2 as some statistics properties of the light is decreasing, and it gives us some coherent light and even anti-bunch time when the G2 is less than 1. So this is in the cavity. And also we investigate the system in its free space. So you can consider a ring of the three-level systems, but here that the parameters are not based on the tryptophan. It's just based on the three-level system as a toy model. So you can see we have three-level systems in a ring, and we have detectors that we can detect the light coming from them, and we can see the directionality of the in fact generated light, and also we can calculate the G2. And so what we have, and the interesting part was that we can find a way to generate the anti-bunch non-classical light with in fact the thermal noise. But there is something. If we go to that, if we have 4 emitters and we pump all of them, so it will not give us the directional light. As you can see, this is the intensity based on the phi. It's this angle of the detector, and also it will not give us the in fact, here anti-bunch light. So G2 is larger than 1, so it's a thermal base. But if by decreasing the number of pump lights, so just we consider the 2 or 3 of the emitters as connecting to the hot bath, we can see by decreasing the number of hot baths. For example, if we have just 1 emitter in contact with the hot bath, it gives us very directional light. So in the phi 0, it will be maximum. And in the same point, we can see that the G2 is the minimum. So it gives us the anti-bunch, in fact, non-classical light. But there is this relation between the number of the emitters and also the emitters that we are connecting with the hot bath and we are pumping. So what we have done is just we calculated, in fact, the system, because it was a very complicated simulations based on it takes long time to simulate, but we went to the decay regime and then simulated the same system for the number of emitters from the in fact 2 to 25. And we saw that by increasing the number of the emitters, we can increase the number of the pumped emitters as well. So there is, in fact, there is some relation between the the ratio of the pumped emitters over the total emitters with the intensity and the G2. By increasing the number of the pumped emitters, we can increase the intensity, and you can see here, for example, when we have 25 emitters and we pump just 4 of them, so we can have anti-bunch light, non-classical light as well. So it gives us that, in fact, a conclusion. When we have a very large network of the three-level systems, if just in fact, a small number of the emitters are connected with some thermal noise, it can give us it can generate the photons. And this is something that we are going to continue to, in fact, investigate the biological systems. For example, the network of tryptophan, that is, we have a large number of the emitters in some configurations and in the structure. So, and we are, in fact, eager to find the results if in a biological system there is such a structure to generate the single photons, that it can inspires us for the quantum technology as well. So this is my results in this poster, and I would be happy to answer your questions, and I can